This video is chapter 14 and it's dealing with electronegativity. First of all, you need to know what electronegativity is. If you have, I'm just going to draw, let's do chlorine and fluorine. Just a simple sketch. If they're sharing electrons in the middle, electronegativity is how strongly this element attracts those electrons, or how strong this atom attracts those electrons. So that's what electronegativity is by definition. So knowing that, let's see if we could do some trends. So the first thing is you want to notice that electronegativity increases to the right and it increases going up. So it should, in theory, be largest on helium. But here's the problem. The noble gases do not form bonds. So all the noble gases are not included in electronegativity. So for electronegativity, I'm going to go highest up and highest to the right without including the noble gases, and I'm left with fluorine. So he is essentially an electron hog. He does not share electrons freely, which is true. So let's look at some trends. If I have beryllium and carbon and fluorine, they are in the same period. So if I wanted to rank those three, I would only have to look at the period ranking. And beryllium would have a lower electronegativity than carbon, which in turn would be lower than fluorine.
I didn't understand the question I heard.
Next, I could compare fluorine and bromine and astatine. And looking at the group trend, the electronegativity increases going up. So fluorine would have a greater electronegativity than bromine and astatine, which means fluorine is best at pulling electrons toward himself. Well, you should ask why. For the A, you want to know why. And we're back to Coulombic attraction. As the magnitude of the charge increases, the attraction increases. So as the number of protons increases, the electrons are held stronger. And that accounts for your left-right trend here. Over here, there's more protons. Therefore, those electrons are held tightly. And when he's sharing electrons, he's holding them tightly. The second explanation will explain the group trend. As the distance between the charged particles increases, that's my dog barking. As the distance between the charged particles increases, the attraction decreases. So the elements at the bottom of the periodic table are not holding their electrons as tightly as the ones at the top. Let's try mixing it up and see if the dog starts barking while I do that. Calcium, barium, bromine, and astatine. What if you have a mixture? Well, then you're going to have to kind of look at stuff. So if I had that mixture, I would look and say, okay, I'm going to first focus on this arrow. Whoever's on the right has a higher electronegativity. So I have a tie between bromine and astatine. And over here I have a tie because calcium and barium are equally on the left. They're both in period or in group 2. So now I'm going to use the second arrow to break the tie. So since barium is lower than calcium, calcium will have a higher electronegativity. So barium is the weakest of these four that I circled here. On the right, bromine is higher than astatine because, according to this trend, he's higher on the periodic table. And I could clean that up because no one wants to grade that. And that would be your final answer.